What's up, my dudes? I'm gonna give you a, a solution to this problem. I know you have the answer. I know most of us have even talked about it during class, but I do want to just make sure you have a reference you can look back at to see, you know, at least one sort of preferred method for doing a problem like this. And we're trying to solve with what we call a component method. You can certainly a totally legitimate way to solve this problem is by making a scaled drawing with a ruler and protractor. All right. What I'm trying to get you to do is understand that you don't have to make a scaled drawing, and you can use, well, just use some trigonometry and some understanding of vector ideas, concepts to solve this problem a different way. All right. With all that said, the first step that I always take in a question like this is to try to make a little sketch of it. All right, I'm not going to use a ruler, I'm not going to use a protractor, but I am going to read and try to draw. So dog walks 3.5 meters south. I'm going to call that vector A. All right, and then 8.2 meters at an angle of 30 degrees north of east, which can be tricky. This means there's east, we go 30 degrees north of there. All right, now, we're not using a ruler and protractor, but if vector A here is 3.5 meters long, and vector B here is 8.2, that's twice as big as 3.5 and then some, so maybe it looks something like that. Not perfect, but it gets the idea across. All right, vector C, this thing goes west 15 meters. That's almost twice as long as vector B, but, not quite. But, at least we're getting the idea of what things look like. So a good little sketch in the beginning can be a big help. And we're trying to find the dog's resultant displacement. And that means from beginning to end. There's what we call vector R. So understanding that that's what we're actually trying to do here is a pretty important step. Okay? And what we are saying is the following. We are saying that vector R, the resultant, is the sum of vectors A, B, and C. And so what we used that to do the other day is say, okay, well, vector R has an x component that has to do with the combination of the x components of all three vectors A, B, and C. And similarly, vector R has a y component that has to do with the combination of each of those vectors' y components. Now, what we're trying to do is turn this into a real mathematical expression, and I need to add things in, before the A and the B and the C. And so what we do is this. We look at each of the vectors. Well, vector A goes straight down, south. So there is no x component. That goes away. Vector B goes up and to the right, so Bx looks like this. That points to the right. I'm going to call that positive. I've just made a decision that says things this way, whoops, I'm calling that horizontal direction. To the right, I'm calling that positive. And therefore, since Cx goes to the left, vector C goes to the left, I'm calling that negative. And furthermore, since all of vector C goes to the left, I'm going to get rid of that little notation that says x at all. It's just the whole vector C. So we have this expression for the x component of vector R. It's the x component of B minus the whole vector C. All right. If we look at the y components, well, first of all, vector A goes entirely downward. So I'll get rid of that notation that says we have to worry about the y component. We use the whole vector. Well, here's by. It goes up. Now, let's see. Vector A is down. I'll make it negative. By is up. I'll call it positive. And vector C goes all in the x direction. There ain't no y component of that vector. So there we are. There's an expression for the y component of vector R. If you want to write this as by minus a, no problem. Same thing. All right? And now, remember, I'll call this theta B. It's to be. And I always measure angles from the horizontal. All right, and that says that we can go to this step. Rx is B cosine theta minus C. I'm not going to derive how I got that. I did that in the notes. Please feel free to look back. And vector R, vector Ry is negative A plus B sine theta. Again, as long as we use the angle from the horizontal, those are the ways with cosine and sine to find the x and y components respectively. Okay, so I think it works out to something like this. Yeah, I think you get Rx is negative 7.9 meters. And Ry is positive 0.6 meters. I guess make sure your calculators are in degrees for sure. All right. Now, once I have these components of the resultant vector, what I like to do is draw them, or draw those two components and then draw the whole vector R. This means that the vector R goes to the left. And notice, since we made our little scale drawing, or our little sketch drawing, yeah, vector R does go to the left, right? And it goes to the left 7.9 meters. Whoops. And by left, we really mean west. And then it goes north 0.6 meters. So that's a sort of to scale sketch of this thing. And then here's vector R, the whole result, which is what we're trying to find. And let's find that angle. That's a theta. Come on, there you go. So now that we know the components of R, it should be pretty straightforward, I hope, to find the magnitude of the whole vector R. I would say, really what we're saying is Pythagorean theorem says that R is the square root of the sum of the squares of the components. And that gets you right about, a little more than, but right about 7.9 meters. I don't know how well I'm following the rules of sig figs here. Not very well, but that's okay. And for this angle, I would say that the tangent of theta is Ry over Rx. And that'll get you about 4 degrees. Okay? How do you know which angle to find? Well, I always find an interior one to my drawing, an interior angle. So you could find this one with north. That would be the 86 degree angle, right? So as long as you show me which angle you're finding, right? I've labeled, here's my vector, there's theta, and that theta is 4 degrees, okay? As long as you're clear about which angle you're finding, I don't care which angle it is. Okay? So, almost an imperative, I would say, make a sketch, right? Understand that we're doing a vector addition problem, so we find the components of R by looking at the components of each vector. We have to take into account things like direction, right? Right means positive for us, left means negative. We said that down means negative and up means positive. That's how we know what sign to assign things. All right, I didn't complete my little dealio over here, right? Up. Whoops, we're saying that up is positive and right is positive. If you want to go all crazy on me and say down is positive, that's fine, as long as you stay consistent with that, that convention. Okay? So that's a big deal, assigning the correct sign based on direction. Third, or I don't know what number step we're on, but make sure that we can handle finding the components of any vector based on the magnitude of the whole vector and the angle that it points at. Fourth, once you know each component, I like to make a sketch of, well, our new vector R. That can help me figure out Two things, its magnitude and its direction. Okay? Okay. Adios.